Hi. Good afternoon, ladies and gentlemen. First of all, thanks very much to Hack in the Box and for this opportunity to share my personal research, which I've been conducted for the past 12 months. Yeah, and then what I'm going to share today will be, I'm going to share about my personal interest. I basically more on this Internet of Things honeypot. So what I've done for the past 12 months is I design and I develop one of the honeypot itself. Then I deploy it just in my personal space basis. Then definitely I'm going to share some of the interesting attack and the data that I've collected for the past 12 months. Yeah, so thank you. Oh, just a quick introduction about myself. You can call me Kean Siong. Yeah, I'm part of this Hack in the Box Malaysia core crew. And then, yep. Yeah, nice one, thanks. And, and a few of us, we have been co-organized and enjoy playing with the CTF itself. And if you haven't been to our CTF arena, please go ahead because this CTF game is going to be end at this another half an hour. So yeah, I mean, this year we have more than 25 teams that are playing. And then definitely it's always very interesting to see different, very smart guy and very intelligent people that try to break the challenge and try to explore the infrastructure itself as well. Yeah, and then personally, I'm part of the Honeynet Project, the Malaysia Chapter. And then I developed this honeypot called as the Dionia Honeypot. And as well as 2 years back, we found that, well, if I want to develop a honeypot, where should I deploy it? Should I need to have a VM or should I need to get a dedicated machine for that? So Christopher and I, Christopher is the Honeynet Chapter, the Singapore chapter. So both of us, we came up with the idea, hey, why not we just develop that honeypots in a small little devices, which is a Raspberry Pi. And then we just push that image out, just release it, and so that we share to everyone around the world. And surprisingly, this HoneyPi project is receiving quite a good number of feedbacks from the community. And then some people, they came back to us, hey, Kian, can you please help me to update it because we'll be able to support for the different versions of the Raspberry Pi itself. Yeah, and then previously I was shared with some of my research in Hack in the Box in Malaysia, and also, yeah, and Honeycon Taiwan. Yep. Yep. So today, for the next 25 minutes, I'm going to talk about this Internet of Things. For me, Internet of Things, I personally feel like this is a buzzword, which is a word that try to correlate everything that we have currently when we try to correlate into one terms. For me, Internet of Things, it just means that device-to-device communications, sensor-to-sensor communication, and definitely is a machine-to-machine communication. So I remember last year, I was having lunch with Christopher Lake. Christopher, are you here? Oh, I think Christopher is at the other door. So he's part of the Honeynet Project Singapore chapter. Then during our lunch, he came me with one question. Hey, Kean Siong, have you observed any attacks on these IoT devices of your honeypot deployment? Have you seen any good and bad attacks, any interesting attacks that came in? These questions really hit me hard because I'm not able to answer this question on the spot because I have no ideas about what is exactly this IoT, although everyone is talking about IoT itself. So with his questions, I try to give myself another 3 questions which I'm going to answer within this 20 minutes time. So the first questions that I have in mind is, what is the network protocol that is going to be related and used in IoT devices? Yeah, this is the first one. And the second one, if we would like to deploy a honeypot, which is the best candidate of the network protocol that we can use? Yeah. And then the third one, definitely, I would like to understand what is the interesting attack that came in, what if I just deploy these kind of small little IoT devices? Yeah, so with this, let's try to explore these three questions. Yeah. So for the first questions, what is the protocol that relate to IoT devices? Personally, I like to say that there's almost around like 6 or 7. There's more of that, this network protocol. Common one, which is SSH, HTTP, HTTPS, SMB, I mean, which are all of us, I think, very familiar with it. Yeah, and then a few protocol that's widely used in IoT devices, for example, SMPP, UPnP protocol, which is a universal plug and play, and as well as this MQTT, which is MQ telemetry transport protocol. Yeah, among all of these 6, well, before we dive into each of the technical itself, let's try to see, in terms of the global activity basis, how much of internet scanning activities that's ongoing towards these 6 protocol. So let's go explore the first one, which is SSH. How many, I believe that this is one of the very interesting part that a lot of people would like to poke with. If I just want to scan a network, if SSH means that it's something very interesting for me. What if I just connect with a normal default password and stuff? I mean, if let's say we can get access into those systems and stuff. So for the past 1.5 years, this is a statistic for 2015 until May of this year. So you can see that in terms of the scannings, there are more than 8 million of destination source people try to scan the whole internet, just try to explore about this port itself. Yeah, and then you can see, there are 2 spikes, which is a spike in the early of 2015. Anyone want to give a guess? What is this spike suddenly appear on early 2015? No worry. Yeah, I'll answer myself, which is, this is at the time the ghost vulnerability that has been found. So once you found vulnerability, a lot of people would like to scan the whole internet. I try to get access into any system that we can get. Yeah, I mean, that's one of the interesting part about this SSH. Yeah, let's dive into HTTPS. For the past 1.5 years, there are 2 big spikes happened around 2000. This is for 2014 statistics. During that time, SSL, the best part, the hybrid vulnerability. So you can see that people are really scanning the whole internet just to try to get access into any good or any vulnerable SSL port, and then let's try to get the private key from that. Yeah. So the third one will be SMB, which is this protocol has been using in a Windows environment for all the Active Directories and printer sharing and stuff. Surprisingly, this port is supposed to be not to be exposed to the internet, but there are still a lot of devices with this SMB protocol enabled over the internet itself. Yeah, let's explore about internet IoT protocol, which is SMPP on port 5222. You may ask that maybe SMPP, where is it used? It's been used in lots of instant messengers. So I mean, this is one of the common protocol, that underlying protocol that been used. So in terms of the past 1.5 years, we can see that they have always tried to reach up to 20,000 or 40,000 of destinations, try to scan the whole internet, try to see if we can get any SMPP server that has been deployed around the world. Yeah. So the 5th one, MQTT. I mean, this is a protocol. I said that is developed by Eclipse. So they are trying to. I mean, this protocol is pretty quiet, which is for the past 1.5 years. It's just around 5,000 of the hosts that in the whole world that are responding to this MQTT port itself. Yeah, until come to this stage, I've explored 5 protocols, and I just want to find myself a good UPnP protocol that I can try to explore. So the 6th one, this one is UPnP protocol that really catch my eye, because while looking at the statistic itself, which is for the past 1.5 years, we can see that people are trying to reaching to more than 30,000 of hosts around the world, and those are really response quite a good one. I mean, say that, okay, I'm the UPnP enabled devices. So in this case, as my first questions, I got an idea about, okay, well, these are the few network protocol that involved in the IoT devices. Yeah, then now, by just looking at just a small statistic of this 6 protocol, now I got my idea, which is the best 2 protocol that I can implement it as inside the Honeypot, which is MQTT and the UPnP itself. So yeah, I mean, I'm going to explore later, and let's see that what is the things that we can I have seen for the past 12 months. But before that, in terms of the IoT protocol itself, IoT devices could be just a sensor that try to detect the speed or try to detect the room temperature, so I can control later up and down. Then it could be deployed in different stations, which is a train station or tunnel or maybe somewhere else. And then by just looking at this, the placement of sensors, they will need to connect to the internet. So the first design requirement for the IoT devices is definitely a small bandwidth, which is I try to keep my payload to be as small as possible. Yeah. And then the second thing, since that the protocol will be will be transferred through like 4G devices or 4G connections, we need to make sure that there's a quality of services in place, ensure the reliability of the whole connection itself. So this is maybe two of the requirement, the main two requirement of the IoT protocol design. And the third one could be definitely if there's some event happening, notification will be just coming in like push notification and stuff. So this is just a brief requirement of the IoT devices itself. So yeah, let's try to explore the first protocol that I'm implemented in my Honeypot itself, which is MQTT. Stands for MQ Telemetry Transport. Nori, maybe you can ask me, hey, Kean Siong, are we really using this MQTT protocol in our daily life? If anyone you have a so-called Facebook Messenger, this is the underlying protocol that I've been using in the Facebook Messenger. Yeah, lightweight protocol, and it's just a common pub and sub, which is the publish and subscribe model. Yeah, and then it just requires a small bandwidth of things. So yeah, I mean, Paho, this particular logo, Paho is one of the application that you can download and play, and Paho is running under, the underlying is MQTT itself. So you will say that, well, Kean Siong, what do you mean that lightweight? So HTTP requests, normal HTTP requests will be having a GET, and then you're having a URI, user agents, or some particular cookie and stuff. While you're putting a payload on top of it, then it will become bigger and bigger. But the basic of the HTTP request could be around 600 bytes, or maybe less than that, around 500, 600 bytes. You can even craft to become a smaller, but from a legitimate browser perspective, which is around 566, I mean, around that. Yeah, but for MQTT, this is how lightweight it can be. It's just a 62 bytes of data, and this is one example that MQTT request that try to subscribe, try to post a subscribe to a channel itself. 10 times big difference. That's why this is how the IoT protocol design itself. So if we explore about how these things work, as simple as MQTT will be you can get one host as broker, which is the centralized server. Then you will have a few sensor, which is so-called the client 1, 2, 3, 4, and try to talk to this main broker. So in terms of talking itself, say that, are you going to connect to you? Second things, are you going to subscribe to the channel or this particular channel A? Later, I'm going to publish my message to you. So once I publish, the other guys will get it. I mean, this is how as simple as this public and subscribe model. If you would like to give it a try, yeah, I mean, this is a public broker, iot.eclipse.org. You can just subscribe to it, which is any topics. I mean, they are using this one for testing purposes. For example, I just try to subscribe to a topic called Hello World, and I public a message to the topic, which is HITBGSEC 2016. And you can see that all these kind of small little egg that are coming in. Yeah, I mean, so this is how MQTT it looks like. So I would say that IoT protocol is somehow it could be designed as simple as this. Yeah. Let's try to explore the next one, which is the interesting one, the UPnP protocol. I believe that lots of us may be really familiar with it, but I will just go through with this with just a quick one. And UPnP protocol is designed to be zero configurations. I just put my device in, yeah, let's connect, that's it. So you will do all the auto discovery and then try to announce itself to the networks, to the whole, to the internal network. Yeah, and then back then, 2012 and 2013, there are lots of nice vulnerability that has been discovered on the UPnP protocol. I believe that with the emerge of the whole IoT devices, this port will be one of the interesting, this network protocol is one of the interesting ones to be explored. So back then, Rapid7 created one of the very nice research on this. But I would say that they say that 2.2% of the whole entire internet responds to this UPnP protocol. 2.2%, it means that 81 millions of IP that responds to this UPnP request, search request. What if all these, maybe half of them have some small little vulnerability is going to create a huge impact to the world? Yeah, and then 81 millions of IP, which equivalent to the whole IP range that assigned to Canada. I mean, that's how the pictures of the whole UPnP protocol in a global network basis. By just looking at one product, just one packet, one network packet, you are going to be pawned on one of the box, which is the vulnerable one. Yeah. So a quick one about how UPnP work. While we plug the devices, for example, I got a printer, I just plug my whole printer into the environment. The first thing it will do is it try to get an address assigned to itself, which is the first phase. I mean, it could be go through with a DHCP and normal stuff. Then the second things they will do is they will try to discover among, from the LAN network, for example, which other devices have the same UPnP enabled with me. So what they will do is I will try to send an msearch request. I'm going to search through the whole network and say, that, okay, well, I have this device or that device, we have a UPnP protocol enabled. And also they will notify the other guys that, okay, I am enabled. I am UPnP enabled. So, I mean, can you guys just respond to me? After all these kind of small data discovery, then they'll go through with the eventing and descriptions, try to get to know that what is the exact device, what does that look like, is it a server, or is it just a router, or could be an oven, could be a toilet. It could be any devices. And after that will be the control and the eventing stuff. Yeah, just a sample of the requests, that UPnP requests that they have. Yeah, so for the past 15 minutes, we explore two IoT protocol. So I implement these two protocol into the Honeypot, and then I deploy it to the network itself. Yeah, let's have fun. So the Honeypot that I choose to implement is, I go with the network emulations capability, which is I try to emulate these two protocol, and then I try to push it out to just an external network, and I want to see what is the things that come back. And the candidates that the Honeypot that I use is Dionia Honeypot. Dionia Honeypot is previously is developed during the configure time. At the time, we just want to we just want to emulate the SMB protocol. We try to respond to all the configures, worms that catching, that's spreading around the world. For example, the traffic came in, the second request, third request, fourth request, until the payloads that came in, the vulnerability, I mean, those payload and shellcode and stuff, and go for the next things to get the binary that came down. So I believe that this Dionia protocol is, the fundamental of the Dionia protocol is good, because for me, in order to implement a new protocol on top of it, is pretty, it's not that hard. Yeah. So this protocol, the Honeypot support for a few different range of protocol, which is SMB, HTTP, FTP, MS-SQL, MySQL, and even a voice OIP protocol. I mean, if you would like to give a Honeypot a try, this is one of the good stuff. Yeah. Although you might see some of the normal attacks, I mean, but it's definitely is one of the good way to go. Yeah. Then for me, I just implement these two protocols, which is UPnP and MQTT on top of it. Yeah. So how I implement for the MQTT, just if you recall that how MQTT worked, so I make my Honeypot to be the broker, to be the centralized. So I'm waiting for any incoming connection that try to connect to my broker. In terms of the protocol itself, I implement 12 different commands that try to respond back to any incoming connection that came in. For example, if someone tried to do a connect, I will say that our connection acknowledge. Then if you try to publish a message, I'm going to log this message in my Honeypot itself. Yeah, I mean, that's the 12 control packets that I implemented. And the second thing is about UPnP, which is interesting. Back then, I'm trying to say that, hey, how can I emulate lots of devices or IoT devices around the world? So I choose to pick up a few profiles. So for example, the first profile I pick is this Supermicro IPMMI profile. So that, okay, I'm these devices. And what if I choose to be a Samsung TV? I can try to say, okay, well, I mean, yes, a UPnP device request came in, and I reply to you, say that I'm the Samsung TV. Although I won't really want to go and buy an 85-inch or 86-inch of TVs and try to do a Honeypot. So I just came by just looking at this small little tweaking of the profile itself. Yeah, so that's the Samsung TV that I implemented in my room. Then I have an Xbox 360 as well. So I mean, that's how I try to emulate different devices through the UPnP protocol. Yeah, I mean, by just looking at these implementations, I mean, we can try to tweak in terms of the config itself about how we want our Honeypot to look like. Yeah. Then after I implement this new protocol. I test it with just a quick Metasploit, and we're able to capture all these kind of incoming requests. And then definitely with the payload itself, the payload is just in the raw format, and later, we can use it for analysis. Yeah. So in this case, I answer my 2 questions. The first one, which is what is the network protocol that relate to IoT? Second questions I've answered, which is what is the best candidate for me in order to deploy, in order to design a honeypot. Yeah. Then now the next one, definitely I'm going to share with you some of the, just 1 or 2 interesting statistics that I've been seeing for the past. Yeah, I still remember the first time last August when I got my honeypot developed. I just pushed it out to the network itself. Yeah, just a small disclaimer, I just have only 1 honeypot in my bedroom. Compared to a lot of people, they have a lot of, like, maybe national cert team, you have thousands of IP space that you can use. But for myself, just for personal interest basis, which I developed this honeypot and I push it from my room basis. Yeah, and then I remember that the first time when I pushed it out, I just very excited. So every 1 hour, I just logging in, if any connections are coming in. Yeah, and then after that, after a while, I feel like, oh no, IoT devices, it seems like the attack is not that promising. Back then. Yeah, so after that, I just put it there. Yeah, but interestingly, I'm going to show you about the first protocol that I implement, which is MQTT protocol. This is the statistic that I've gained for the past 1 year. Looking at the graph itself, oh no, a year. I've been collecting just less than 100 incoming connection to my bedroom. So I'm pretty disappointed, by just looking at the graph itself. But it matched with this pattern is actually matched with what Internet Sandstorm Center, what they observe in the whole internet, which is they just seeing maybe 5,000 within a year from a lot of sensors they deploy. And I only have 1 sensor, and I catch around 200, around less than 100 requests. It makes sense, right? Yeah. So this is what I've been seeing. Then in terms of the incoming connections, I'm able to fingerprint all those incoming connections. For example, what is the client ID that they use? If you remember that, there's one, I mentioned about one PAHO, this application, which is they have been using the underlying is MQTT protocol. I'm able to fingerprint a few ID that came in from that. But too bad, there's no anyone really connect to my broker and try to do any public or subscribe and stuff. But it could be interesting to see that. So until this stage, I'm pretty disappointed. But while I'm looking at the next, which is UPnP protocol, it really catch my eye, and it really catch my attentions on this UPnP protocol. For the past 12 months, just by looking at just one single IP base, single honeypot basis, I've seen 3.2 million of a record that connect into my bedroom. It doesn't make sense, but it happens. So by looking at this 3.2 million of incoming requests, I tried to filter out about the payload itself, and I saw that basically majority of the incoming request is the one that I'm showing here, which is with the host IP address of the 239.255.250. Yeah, this is one of the broadcast address, and this is a legitimate and normal UPnP request. And from time to time, you're seeing some request, which is the second one, the one that with the host of some specific IP address on it. I treated this as just a normal, could be just a scanning activities. Yeah, but I try to simulate the whole pictures. I try to generate this graph. Yeah, this gives me much of a more interesting data. I would say this is a beautiful graph that I have from my bedroom. Yeah, so all the different the spike itself is indicating a lot of incoming requests to my sensor. And by just looking at a huge spike, which has happened during June, 2 months back, I saw that my honeypot has been involved in part of the denial of the service, DDoS activities. By looking at this perspective, I believe that a lot of IoT devices has been non-intentionally has been involved in a UPnP, this kind of DOS, but maybe none of us really know about it, unless we really checking about the logs and stuff. Yeah. So the maximum, I think it hit on 250 thousands of requests in a day basis. Yeah, I'm very keen to understand what happened in June. So I look at the June statistics, which is in the day basis. I have 150,000 of UPnP requests that came into my little honeypot, and I try to filter out about the incoming request source address, which is they're coming for the 4 or 5 spoof IP address. I believe that those are the destinations that might for the DDoS to be happen. Yeah, and then in terms of a minute basis, I think the maximum I have around 800 or 1,000 requests that came in just in a per minute basis. Yeah, I mean, it's pretty interesting to see all this kind of stuff that happens just inside my room. By looking at the payload, I try to check what is that happen, and I check the payload itself is consistent with a few public available scripts, the DDoS scripts that they came in. For example, some of the pattern is the source. UPnP request supposed to be the source destination IP is to be a 1900, but then the source IP, it came also to be a 1900. I mean, this is one of the pattern. And the second pattern could be the host. Suppose the host value, the header, should be HOST, the small capital, but they changed to be a HOST with a, big capital. Yeah. So I mean, this is some of the small patterns that I've seen for the past 12 months. Yeah. So the next one, yeah, I'm going to show you how my bedroom honeypots look like. So yeah, this is one of that. Yeah. Then another one is this another tree, which is in the daytime. Then nighttime, it turned out to be such a nice blinking things in my room. Daytime, nighttime, daytime, nighttime. Yeah. Yeah. So yeah, I mean, I'm just doing this IoT honeypot for fun, for personal research basis, and because I'm very keen to understand about the attack vectors that on the Internet of Things devices. Yeah, I will continue to develop this IoT capability on my honeypot, and I believe that if we deploy in such a big scale basis, definitely we'll see more attacks and more activities. And in terms of involvement in the DDoS, we can see even more new exploitation that came in, or all the scanning activities that around the world itself. So if you would like to involve in this development, or would like to download it and play with it, I mean, this is my GitHub. And also, if you would like to, if you say that I don't have a big machines for a dedicated honeypot, what you can do is just get a $35 US of that Raspberry Pi, and then just download the image from our Honeypot project. Then you can, I mean, just delete it, just try to deploy it. Yeah, I mean, hopefully we're getting a lot more interesting activities. Yeah. So, any questions I can help to answer?
Okay. So, any questions from the floor?
Yeah.
Very interesting talk, Kean Siong. I'm really enjoying myself to listening to it. I have one question. Through your research, right, did you actually able to find out like most from this source IP, where do they originated from?
Good questions. Yeah, definitely. I mean, for me, at the current basis, what I have is for the honeypot itself, it has the capability of recording all the incoming. What is the source IP, for example? What is the payload itself? And then we could record all these things in the byte stream, and then we can replay the whole traffic if you would like to. Yeah, but I mean, I've seen a lot of those source IP is a spoof IP address, which is the target of the denial of the service, that target itself. I mean, I would very keen to understand about entire UPnP protocol if I can really pinpoint to the exact who is the guy who behind the scene. I mean, if you have any idea, I mean, we can try to work on it together. Yeah.
So even from the spoof source, where was it from?
I have seen a few spoof source, and those spoof source, I believe, is the destinations that the target of the.
You're not going to give me any countries, is it? I'm hoping to say like, okay, yeah, from Russia or China or US.
I think one of them is from China. I mean, that spoof IP address could be targeting one of the China servers or somewhere else. I mean, it's one of that. I mean, this just based on what I've observed.
Thank you so much.
Yeah.
Any more questions?
So I just have one question for you. Although you looked at those 3 protocols, Were there any other protocols that you found were being scanned a lot more aggressively?
I mean,
Other incoming ports. Were you monitoring or logging all ports coming in?
I believe that there could be more protocol that we can try to monitor with. I mean, for example, I know that some of the research they monitor about Telnet, which is Telnet protocol, and try to see that if any incoming things that came in, and they try to capture all the commands that they deploy. And also I've seen some people, they deploy IoT Honeypot by looking at the webcam basis, which is like create a real webcam. Some guy they connect in, and then they try to move my webcam and try to if let's say they can move my webcam, they can try to up and down, left and right.
That's a dangerous thing to do in your bedroom. Thanks.
Yeah, and then definitely there are a few more IoT related protocol. I think it is good to explore, definitely. Yeah.
Okay, so any more questions from the floor? So if no, then we thank Kean Siong for an interesting talk.
Thank you very much. Thank you.